Hello everyone. Good morning, good evening. My name is Jeevendra and I work with the Customer 360 team in the SBS Seller org. Today we are going to learn about AutoGen framework. I'll walk you through the basic concepts and building blocks in AutoGen. We'll also look at some code snippets, which I hope will bolster your confidence to start building LLM apps using AutoGen. I'll keep switching between this presentation and the VS Code, and I hope that's okay. At the end of the session, you can expect to have working knowledge of the AutoGen framework. Okay, let's get started. So this is the agenda for today. Uh, I know a lot of things that are on the agenda might not be very intuitive as of now. So before we dive into understanding the AutoGen framework, let's first develop an intuition for why we might need a framework like AutoGen. Let's take a use case where we use LLMs like ChatGPT to write code for a coding problem. So what does that flow like? A human user provides GPT with a coding problem and asks it to generate code in their preferred language. GPT responds with the generated code. However, the human user cannot be completely sure if that code will work without executing it and running it against some test cases, right? So the human user goes and executes that code in a compiler or executor against some test cases. If the code works, then this conversation between the GPT and the human user ends. If the code does not work, the human user informs GPT that they are getting this and this error, or there is such and such discrepancy between the expected output and the output given by the GPT's code. GPT then apologizes and rewrites the code. Human user again executes the newly generated code and checks if it works this time or not. If the newly generated code also does not work, human user again prompts GPT about the discrepancy between the expected output and the output given by the new code. So this conversation goes on and on until human user gets the correct working code, right? In an ideal world, the human user would expect GPT to return the code in one go. This is also known as zero-shot prompting. So to solve the coding problem, one could employ a better and a bigger LLM model. For example, GPT 3.5 has 175 billion parameters, in contrast with GPT-4, which has close to 1 trillion parameters. So it's highly likely that the code generated by GPT-4 is going to be much more correct than GPT 3.5. But all of that comes with a cost, right? So if you look carefully, there was a conversation happening between GPT and the human user to accomplish the task of solving the coding problem. And that conversation wasn't fully autonomous. So it would have been much better if the GPT, which I'll call as the code writer, and the human user, whom I'll call as code executor, could talk between themselves autonomously and arrive at the correct code, right? So frameworks like AutoGen make this process autonomous, reducing the need for manual intervention. So this is just one of the many use cases which could be solved using AutoGen. So instead of having LLM generate its final output directly, an agentic workflow will prompt the LLM multiple times, giving it opportunities to build step by step to a higher quality output. Right. Now
Hey,
let's see.
Jeevendra. Hello.
Yes.
I'm seeing the first slide itself, the second slide. Are you changing it or?
No, I'm not changing it. I'm not changing it yet.
Okay.
Yeah. So yeah. So now let's see what all capabilities AutoGen offers us to make these conversational workflows. So these workflows are also called as agentic workflows. In fact, Microsoft also published a paper last year in December called Era of Agents, which alludes to the fact that the future of AI development is going to be agentic. So this paper is attached on the references slide of this presentation. So yeah. Now we'll get to what agents are in a moment. Before that, let's quickly go through an introduction on what AutoGen is. So AutoGen is powered by collaborative research studies from Microsoft, Penn State University, and University of Washington. So AutoGen is a framework that enables development of LLM applications using multiple agents. And they can also converse with each other to solve tasks. So it supports diverse conversation patterns to create complex workflows. AutoGen agents, they are customizable, conversable, and they also allow human participation. They can operate in different modes by employing combination of LLMs, human inputs, and tools like calling an API, right? Okay, so I talked a lot about agents in my conversation. So let's quickly get to what is an agent. So there are many definitions of agents, but in AutoGen, an agent is an entity that can send messages, receive messages, and it can also generate a reply using LLM models, human inputs, and a combination of them. So this abstraction, right? It not only allows agents to model real world and abstract entities like people and algorithms, but it also simplifies implementation of complex workflows by making a collaboration between these agents. So AutoGen is extensible and composable, right? You can extend a simple agent with customizable components, and you can create workflows that can combine these agents to maybe make a more sophisticated agent. Uh, and also these implementations are modular and they are also easy to maintain. So now let's get to a built-in agent that is present in the AutoGen framework. It is called as the conversable agent, right? So I'll also show you the code side by side. So conversable agent. So it is an example of a built-in agent in AutoGen. So if you see the conversable agent takes in a list of LLMs, right? This LLM could be the OpenAI LLM, or it could be a local running LLM as well, right? And if you see, there are three more things: code execution config, function map, and human input. So it takes these following four components, and you can switch each component on or off and customize it to suit the need of your application, right? LLM, for example, when LLM is on, right, it enables the agents to converse in natural languages. Code executor, when that config is on, so it lets you execute code. And function or tool executor, basically this function map, if this is on, then it can help you call different functions or APIs, right? We'll get to what is the human input mode in the further slides. So let me just go through this simple code of a conversable agent. I hope my VS Code is visible to everybody.
Yes,
Okay.
we can see.
So if you see here, we have this conversable agent. Is this zoom clear, or should I zoom it more?
It is clear.
Okay. So if you see here, we have this conversable agent, which is a built-in class in the AutoGen framework. Now, how to run these Python notebooks that are here? I already have created a repo, and in the repo there is a README file where all the steps are mentioned, how you can play with this around. So that is also attached on the references slide. So for now, I'll not get into what to install and how to run this. So we'll just quickly run through these notebooks to have an intuition of how things work in AutoGen. So here, if you look at the conversable agent, right, its name I've just given as a chatbot, and I've given an LLM config here. So here, this LLM config, basically, you have to put in the Azure OpenAI's LLM deployment name, OpenAI key, base URL, and things like that, right? Simple config. and you attach this config to this conversable agent. And for now, if you see the code execution, function map, and human input, I have switched off. Now I'll ask this agent, right? This agent to generate a reply. I'll pass in an initial message, initial context, saying, tell me a joke. So let me just very quickly run this. So this conversable agent is connected to a LLM. So it is going to talk to the Azure OpenAI and get a joke. So if you see here, tells a joke. Why don't scientists trust atoms? Because they make up everything. Okay, well, a very stupid joke, but yeah. So this is where you see the conversable agent connected to a LLM. Now let's go to another example where we have more than one agent. So we have these two conversable agents talking to each other. So let me just go through the code. So there's this agent called Kathy. So here we have defined a prompt saying your name is Kathy and you are part of the duo of comedians. We have attached it to a LLM. We have set the temperature as 0.9 to just make it a little more creative. Similarly, there is another conversable agent here called Joe. Here also we have defined a prompt saying your name is Joe and you are part of a duo of comedians. The temperature is given as 0.7 and attached to the same LLM. Now, these two agents, they can bounce off each other, talk to each other. So let's just see how that is happening. So Joe says to Kathy, Kathy, tell me a joke. Then Kathy responds to Joe saying, sure thing, how about this one? Why don't skeletons fight each other? They don't have the guts. Okay. Then again, Joe responds to Kathy, that's a good one, Kathy. Here's one for you. Why did the scarecrow win an award? Because he was outstanding in the field. So if you see, now they are like bouncing off each other, telling jokes to each other, right? Essentially, they are talking. Okay. Now, if you see, here the Joe agent initiated a chat with Kathy and passed in an initial context, initial message saying, Kathy, tell me a joke. And this started off the conversation. So here we have defined one more thing called max turns equal to 2. So that at some point the conversation should stop. Otherwise, these agents can keep chatting endlessly, and that will consume a lot of tokens, right? So that brings us to the next. One second. That brings us to the next topic, which is the chat termination, because we need to ensure that these agents, AutoGen agents, they do not keep talking endlessly. At some point, the conversation should terminate, right? And why this is important? So it's because in any complex autonomous workflows, it's crucial to know when to stop the workflow. For example, when the task is completed, or perhaps when the process has consumed enough resources and needs to either stop or adopt different strategies, such as user intervention, right? So if you let the chat agents chat endlessly, they can consume a lot of tokens. Hence, we need mechanisms to terminate the chat. So AutoGen natively supports several mechanisms to terminate conversations. Currently, there are two broad mechanisms, if you see here. One is specifying the parameters in the initiate chat, where I showed you how Joe was trying to chat with Kathy, right? So you specify parameters in the initiate chat, determining like when the conversation should end. And the other way is you configure an agent to trigger the termination, right? So when you define individual agents, you can specify parameters that will allow agents to terminate a conversation off based on a particular condition. So let me just show you a few examples of chat termination. So here, one I already showed you, this max turns. You can define how many turns they can take. And now here, there's something called max reply. So here we have both the agents, Kathy and Joe. And if you see for Joe, we have defined the maximum consecutive auto reply should be 1, right? So if I run this now, Joe will only talk once, right? So Joe will first initiate a chat with Kathy, asking Kathy to tell a joke, and then it will respond only once in the series of jokes, right? So let me just quickly run this. So if you see here, it says, Kathy, tell me a joke. I think it just used the cache. I'll just remove the cache for now and run it again. Probably they'll tell the same jokes, maybe. So Joe says to Kathy, tell me a joke. Kathy tells a joke. Then Joe replies to Kathy with another joke. And Kathy then replies to Joe. But if you see, Joe only talked once because we had set the maximum consecutive auto reply as 1. So this is one way of terminating the chat. The another way of terminating the chat is while we are defining the agents, right? So if you see here in the agent Joe, we have added a condition saying if there is goodbye in the message from the other agent, so we should stop the conversation. So this is the condition that we have defined while defining the agent itself, right? So if you see here, while we are initiating the chat, Joe is initiating the chat. It is saying, Kathy, tell me a joke, and then say the words goodbye. So because Kathy will say the words goodbye, so the chat is going to terminate. Agent triggered termination message. So here Joe says, Kathy, tell me a joke and say the words goodbye. Kathy says a joke and replies goodbye, and the conversation ends. So these are the two different broad mechanisms for chat termination. So as I showed, you can define parameters in initiated chat, or you can do a agent trigger termination using these maximum consecutive auto reply and termination message. Okay, now this brings us to the next topic, which is human feedback in agents. So we saw that the conversable agent class and understood how to create autonomous agents, right? Where we had set human input mode as never to accomplish several tasks. Now, we also saw how to properly terminate a conversation between agents, but many applications may require putting humans in the loop with agents, right? For example, to allow human feedback to steer agents in the right direction, specify goals, etc. Right? So in AutoGen's conversable agent, so the human in the loop, if you see, it sits in front of the auto reply components, right? So auto reply components are where your agent is connected to LLM code executed, etc. Right? So human in the loop component sits in front of the auto reply components. So it can intercept the incoming messages, right? Whatever messages coming in, and decide whether to pass them to the auto reply components or to provide a human feedback, right? Or do auto reply, right? So I'll just show you through code these strategies of human feedback. So one second. So essentially, there are 3 modes for human input, right? So this mode is specified in that config that I showed you, where the human input mode argument of the conversable agent, right? And these 3 modes are one is never, which means human input is never requested. Agents are chatting autonomously. And then the second is terminate, right? So human input is only requested when some kind of a termination condition is met, right? So in this mode, if the human chooses to intercept and reply, the conversation continues, and the counter that was said used by the max consecutive auto reply, that is reset, right? And then the third is always, where human input is always requested, and human can choose to skip and trigger an auto reply, or intercept and provide feedback, or terminate the conversation. So in this mode, the termination based on max consecutive auto reply is ignored, right? So let me just show it through code, the three strategies. I'll just delete the cache, otherwise it is going to generate the cached responses. Okay, so hello. Is somebody asking a question?
Okay, carry on.
Okay. So yes, so here I'm now going to show you code about the strategy where human input mode is always present, right? So we have this agent, conversable agent called agent with number. So here we are given a prompt saying you are playing a game of guess my number. You have the number 53 in your mind, and I'll try to guess it. If the guess is too high, say too high. If I guess too low, say too low, right? This is attached to LLM, and in the termination message, if it gets 53, then it terminates the conversation. And here the human input mode is set to as never. Now we have another agent, which is nothing but human proxy, right? So it can do auto replies also, or humans can choose to intercept it also. So here human input mode is set as always. Now this human proxy agent, it is going to initiate the chat with agent with number, the first agent, and pass our initial message as 10. So let's just quickly run this. Human input mode always. So if you see, human proxy started a chat by sending a message number as 10 to the first agent. Then the agent replies saying too low. Now if you see here, it says provide feedback to agent with number, right? So now here the human in the loop can choose to skip this, right? And or type exit to end the conversation. But let's say I will say, okay, 32. So it says too low, right? So if I say 78, it says too high. So it is kind of doing a binary search, I think. So if I say 53, so it says, yeah, so it ends the conversation because 53 is the number that was in the mind of the first agent. So you can see how humans can also provide feedbacks, or they can also, enter to skip and use the auto reply. So this is one human input mode, which is always. Then other human input mode can be terminate, right? So the same example, we have the agent which has a number in the mind, and here the human input mode is set to as terminate. So it will ask for human input mode until the game is terminated, right? And this there is another agent that we have defined who's going to guess numbers. Now this is not the human proxy because we have set the human input mode as never, and this agent with number, it initiates a chat. Okay, so let me just run this. So now if you see, they are chatting with the, so agent with number says, I have a number between 1 and 100. And agent guess number says, okay, I'll start with 50. Is it 50? So agent with number says, no, it is too low. Then again, agent guess number says, how about 75? Now, if you see, agent with, here we have asked the human input mode as terminate. So that's why it is saying, please give feedback to agent guess number. Press enter to skip and use auto reply, or type exit to stop the conversation. So if I just press enter, it will auto reply, generate auto reply. It will just pop in some random number. Or now, as a human, I can also choose to exit this. So this is yet another way of chat termination. And the human input mode never, that we already have seen, right? Where human input is not at all needed. Agents can chat autonomously. Okay. So now this brings us to the next component that we can switch on or off, which is the code executor. So I initially started taking that example where you ask LLMs to write code and you have to execute it by yourself. So in AutoGen, a code executor is a component that takes input messages, like messages containing code blocks, and perform executions and outputs the message with results, right? So essentially, AutoGen provides you two ways to execute code. Either locally, you can execute the code on a local machine, or you can execute it in a Docker container. So one way is to execute code directly in the same host platform where AutoGen is running, right? Your local operating system. So it is for development and testing, but it is not really ideal for production, right? As LLMs can generate arbitrary code. So other ways to execute in a Docker container. So if you see here, an agent which is plugged in with a code executor, whose code executor config is set to true. So it takes in a message with code blocks, right? It writes the code to a file, executes it, right? And on the console gets some output, reads it back, and then returns the message with the execution output. So this is what this agent is essentially going to do. Let's quickly look at the example. Here I have one example for code executor where we execute the code locally. So what we have done here, we have defined a code executor agent, right? Now, if you see here, the code execution config is set to be on, and LLM config is set to be false. And human input mode, we are asking always for humans to intercept in this. So this is my code executor agent, right? And then similarly, I have a code writer agent, right? Code writer agent is connected to LLM, and we have defined a prompt here, like how you should write the code. So we have defined this prompt saying you are a helpful AI assistant and you can solve tasks using coding ability. So it is essentially a big prompt which lets LLMs write code. Okay. Now, what this code executor agent is going to do, it is going to initiate a chat with the code writer agent with this initial context, initial message saying it will give us today's date and say, write Python code to plot Tesla's and Meta's stock prices gains year to date and save the plot to a file name stockgains.png. Okay. So let's go ahead and execute this. So now if you see the message here, code executor says to code writer agent, today is this date and write Python code to plot Tesla's and Meta's stock prices against this. Now, what does code writer agent say? It says, it tells you how to do this. So it says that first fetch the stock prices of Tesla and Meta, calculate the YTD gains and plot the YTD gains and save the plot to a file name this. So it says that we'll have to use the Y-finance library of Python to fetch the stock data and matplotlib to plot the data. And it also tells you what will be the complete Python code. So this is LLM writing the code. So here, if you see, the Python code is there. It imports a bunch of libraries and then defines the tickers and then plots the graph. So this is the code. Now it says that says to the code executor agent, please save this code in a file called this and execute it. So now see, the human in the loop is now triggered, and it says provide the feedback to code writer agent, right? If you think that code writer agent has done some mistakes, provide some feedback, or you can choose to auto reply. So I'll choose to skip. Once I skip this, what does code executor agent say to code writer agent? It says that, hey, the execution failed. I tried to run that code that you gave me, but somehow this this Y finance library is not available. So we are getting this error module not found error. Now, once this happens, the code writer agent replies is, The Y-Finance library is not installed in your system, so you go ahead and first install it. Install Y-Finance and Matplotlib, these two libraries, and it tells it how to do that. Now, again, it is asking for the human to provide input to the code writer agent. I'll again choose to skip this. So again, code executor says, hey, the execution has failed because of some issues. Again, the code writer agent replies with what exactly is wrong. So it says you can run the pip install command directly in the command line. And then again, human is asked for some feedback. I'll again choose to skip. I'll again choose to skip. They are still talking to each other. So I hope I think they have. So here is the Python file that is generated. I'll again choose to skip. Something is wrong. Well, it was executing code until yesterday, so there is some issue, I think. But I'm sure that this works, and it writes the complete code, and it also generates the output. There's something wrong. I'll have to check again maybe. But it ideally what it does, it generates the code, and it also plots the graph and saves it to a PNG file. So somehow it is not doing it right now because some or the other issue is there. But this definitely works. I have tried it before. Maybe we can choose to skip this for now because in the interest of time. But it definitely works. I think you can try executing this Python notebook on your local machine, and you'll see that this works. Okay. So this was about code execution. I'm sorry that this did not work this time, but this should work. So another thing that we spoke about, four things we had spoken about. One is the agents could connect to LLMs, agents could connect to code executors. And then the third thing was agents could use any function or any tool to work with as well, right? Which is essentially calling some kind of a API or some kind of a function. So let me just. So tools are basically predefined functions that agents can use, right? So instead of writing arbitrary code, agents can call tools to perform actions, right? Such as searching the web, performing calculations, reading files, or calling your APIs as well. So because you can control what tools are available to an agent, you can control what actions an agent can perform, right? So if you are using any tool, you need to it must be registered with at least two agents for it to be useful in the conversation. So the agent registered with the tool's signature can call the tool, and the agent registered with the tool's function object can execute the tool's function. So I'll just show a very small example on how to do this. Let me just quickly remove the caches. So I'll show you this example of agent with tools. So here, what we have done, we have defined a very simple function called calculator, which calculates addition, subtraction, things like that. And then we define an agent called assistant. And we are saying that, hey, you are a helpful AI assistant, and you can help with simple calculations. And you should return terminate when the task is done, right? And then there is this user proxy agent, which basically will terminate the conversation when it gets the terminate keyword in the reply, right? Okay. So now we will register the function, register the tool that we have defined with these two agents, the assistant agent and the user proxy. And finally, the user proxy is going to initiate a chat with the assistant saying what is the output of this calculation. So let me just quickly execute this. So user asks to assistant, what is this calculation? So now if you see they are now chatting. So finally it generates a response that this is 200. Again, now we are using the operator here as division. So that execution is done. Finally, at some point, this conversation ends. So the result of this is this value, and then the finally conversation is terminating. So here we essentially called a function, but this could also be a remote API or things like that, right? Okay. Now, clearly, we saw that there is a lot of conversations happening between these agents. So definitely, AutoGen is something that supports a different kind of conversation patterns. So two-agent chat is the simplest form of conversation pattern, and that we have already seen. Now, let's look at so two agent chat is really simple, right? That we already saw that two agents are chatting with each other, and whatever they have chatted, that history is summarized and chat result is presented to us. Now the other one is the sequential chats. So the name of this pattern, I think, is self-explanatory. It is a sequence of chats between two agents chained together, right? Chained together by a mechanism called carryover, right? So which brings the summary of the previous chat to the context of the next chat. So this pattern is useful for a complex task that can be broken down into independent subtasks. So if you see here, initial context and message is fed to agent AB, and whatever they chat, that history is carried over to the next set of conversation, and the next set of conversation, and the next set of conversation. So I'll just show a very small piece of code for this as well. So chat pattern, sequential chat. So here what we have done, just defined few agents. This agent is called number agent. So what it is connected to LLM. We are saying whatever numbers I give you, you return me that number. That's all you should do. Then there is an adder agent, which adds 1 to each number that is given to it. Then there is a multiplier agent, which multiplies it by 2, whatever number it is given, and subtractor agent subtracts 1. Divider agent divides by 2. Okay. Now this sequential chat begins. So we the number agents initiate a chat with all of these agents. So first number agent is going to chat with the adder agent, and then their result will be passed on to the chat between number agent and multiplier agent, and that result will be passed between number agent and subtractor agent, and so on and so forth. So let's just quickly run this. So now if you see, the chat has started. So number agents chats with adder agent, providing it number 14, which was the initial message that we had given here. And then adder agent replies to a number agent by adding 1 to it. So it gives 15. Then the number agent talks to the multiplier agent. Multiplier agent multiplies it by 2. And then the number agent talks to subtractor agent. And this goes on and on. So this is how the sequential chat works, right? Now there is yet another chat pattern. In fact, there are two more, but I'll only go into one, and just for the interest of the time. So another conversation pattern is the group chat, right? So now in case of group chat, so we have seen conversation patterns that involves two agents or a sequence of two agent chats. Now, AutoGen also provides you a more a general conversation pattern called group chat, which involves more than two agents, right? So the core idea of group chat is that all agents contribute to a single conversation thread, and they share the same context. So this pattern might be useful for tasks that require collaboration among multiple agents, right? Now, if you see, this group chat is orchestrated by a group chat manager. So in the first step of group chat, the group chat manager will select an agent who has to speak. And then the selected agent speaks, and the message is sent back to the group chat manager, who will broadcast the message to all other agents in the group. This process repeats until the conversation stops. Now, this group chat manager, it can use several strategies to select the next agent. Probably it could do round robin, it could do random, manual, auto. So these are some bunch of strategies which the group chat manager uses to select the next agent. So I'll just show you a small code for this group chat pattern. So essentially here, what we have done, we have defined developer agent. So this agent is essentially a software developer who will provide the technical feasibility for a feature, right? Similarly, there is this tester agent who's going to provide an estimate of the time it will take to test that feature. And then there is a product manager agent who will provide an estimate of the time that it will take to plan a feature and what all steps will be involved, right? And then there is the engineering manager who has to give an estimate of time that it will take to deliver that feature, right? Here is the group chat manager. It takes in all these agents: developer agent, tester agent, product manager agent, engineering agent, things like that. And here we have defined a maximum round of 3 that, okay, you guys chat, but keep the round till 3, don't chat endlessly. And the group chat orchestrator has selected a selection method of round robin, right? Okay, now finally, what happens here? Chat engineering manager is going to initiate a chat with the group chat manager, right? Saying, I want to develop a parking management system. So now you guys talk and tell me how I can do it. So let's just run this. So engineering manager says to chat manager, I want to develop a parking management system. So the next speaker that has been selected by the orchestrator is a developer agent. So developer agent provides the technical feasibility, right? What will be the key components, backend system, payment integration, things like that. And then finally, the tester agent is selected. Not finally, in the round robin, the tester agent is the second one that has been selected. So tester agent also provides the estimate, what all time it will take to test planning and things like that. And then, okay, where was the... Okay, I think we defined the rounds only 3. That's why the product manager agent was not called. Yeah, so a product manager agent was not called by group manager to talk. So I think because we just made this max round as 3, if we should have made it 4, so product manager would also get a chance to speak. Well, this is how the group chat essentially works, right? Then there is one more pattern called nested chats. So I'm going to leave this pattern for you to study by yourself. So AutoGen documentation is already available. You can go and read about it. That references that link to AutoGen documentation is on the reference slide at the end of this presentation. Okay, no,
Thank you, everybody.
Okay, thanks everybody for listening to this very patiently. Thanks a lot. Okay, bye-bye.
Thank you.